Ioan, actually, I'm the guy right here, and my name is on the slide. I work in cybersecurity with Orange Romania, and for the next 45-ish minutes, because I fully understand that I'm standing, my pitch is standing right between you and lunch, the lunch break. I'll do my best to go over some of the things some of the interesting and innovative things we're doing in the beyond 5G space, specifically in the security orchestration field. This is a technical presentation of sorts, but I'll do my best to keep it light because, again, we are right before lunch. And we'll go over some of the interesting things that actually pushes technology beyond 5G and towards the networks of the future. We'll discuss multi-domain networks and continuums. These are notions that might sound a bit off to some of the audience, but I'll do my best to go over what they mean in practice and in operations. We'll discuss the state of the art in 5G security, and then we'll focus on one interesting research and innovation action. It's a project called Rigorous. This is an acronym for something, for a phrase that's highly complicated. But this is a project that aims to push security orchestration beyond the state of the art. And we'll, of course, discuss Orange Romania's use case. The goal that I'm trying to achieve here is to somehow distill a better understanding of what 5G actually is and what moving beyond 5G actually means for network operators, of course, but even for yourselves, as I'm fairly certain that most of you are working in some, or at least contributing in some type of DevSecOps environment. So without ado, what is 5G and what is actually 4G, 3G, and even 2G? These are mostly marketing statements. And it's what we telcos essentially do is we follow a set of standards that are curated by a association of network operators, technology vendors, and technology providers. This association and standarding body, it's called 3GPP. And for each release of the standard, we add something to the network. We add some form of capability or capacity to the existing stack. What our marvelous people in the marketing and business-to-business side of the telco do is they try to cluster together subsequent iterations in one catchy and easy to follow generational evolution type of context. This is why we we still have 2G networks, 3G, 4G, 5G, and so on. But essentially, each iteration of this set of standards that we are actually implementing in our networks will drive the capabilities of said networks. This means essentially that we can provide you with better services. We can provide you with a more diverse and range of services, and we will, of course, improve aspects such as security in our networks. We are now here at release 16. Of course, some of my colleagues in the audience will probably have to have a word with me on this. Let's say that we are at release 16, just in order to keep this presentation as short as possible. And we are now in 5G land. So starting with release 15 of the 3GPP sets of standards, we've moved from 4G LTE to 5G. And at some point in the future, I'm not sure when, we will probably move to the next denominator. I've represented, it is represented here as XG because I'm not sure how it's going to be called. Maybe 6G, 7G, I'm not sure. But anyway, the generational leaps between the various implementations and deployments of networks are specifically tied to the specifications of the 3GPP books of standards. So we're now here. We're in 5G. And 5G, it's a pretty interesting land when it comes to cybersecurity and security as a whole. Moving from the previous generation of networks, we had to adapt to virtualization, essentially, because we made this, I mean the whole telco business, we made this huge leap from monolithic assets, monolithic components of the networks, which are highly inefficient compared to modern and comparable industry standard virtualization functions. And we've moved to virtual land, where we can decompose, then federate the various components that make up a 5G network. We are running our 5G networks on a common composable core. You can visualize it as a set of clusters in a federated environment. We are now defining the networks in software, so we are not by any means ruled by policies and actual cabling, right? Layer 1 to layer 4 stuff. We are now, most of the networks are SDNs, are software-defined networks, and the functions in said networks are virtualized, right? Network function virtualization, right? The routing instance that actually makes your TikTok session route through whatever server in not China it goes to is most likely a virtual network function as of now. And of course, we have a, in 5G, we integrated the concept of slicing. Slicing is one of the sweet and very interesting things in this new deployment, because it allows an operator to isolate, to silo some specific SLA, some specific type of service with a given SLA and given metrics to a specific use case or to a specific end user. Slicing will enable concepts such as private networks or private slices, right? Think of, I don't know, a use case to which you need some higher degree of privacy and isolation than the commercial network provides, is already providing you. You could set up a slice with a different configuration than the commercial one, and you can have your end user equipment route the traffic to that slice. And on top of everything, and at the same time as a basis for everything, we have management and orchestration. Because everything, again, is decomposed, it can be federated, so we need to orchestrate and automate the various functions that actually keep the network alive, the network functioning, right? From stuff like automated deployment, automated scaling, to detection of anomalies or detection of threats. The management and orchestration part is essential here, because without it, 5G networks would simply not be able to provide services as they are right now. But we are moving from 5G, and we are evolving through the different 3GPP rule books to the next generation of networks. And I know that this seems a bit off, while most of us are still using LTE or 5 or 4G in some areas. But again, the technology is ticking at its own pace. So these things are happening. So from a orchestration and security perspective, this migration towards the new capabilities of the future, of the networks of the future, will bring some opportunities and some very, very sweet new technologies. The first one is continuum. A continuum, although not yet defined as is, but can be accounted for as a chain, a chain of communication, a bidirectional chain or multi-directional chain of communication between some end user equipment or some IoT device through different network operators and their different environments, such as the radio access part, the edge part, where you do some processing for the data that's coming off that UE or IoT device, through different cores of different networks, so in roaming scenarios, for example, and then through some private or public cloud deployment. This is the actually, it's somehow reshaping the internet to actually include everything that is now in 5G land. And these continuums, well, they pose specific challenges when it comes to security and orchestrating security, because you have to deal with a lot of devices, you have to deal with a lot of domains, and you have to deal, of course, with different vendors, different technology stacks. Furthermore, the management and orchestration that's already part of 5G is, of course, adopting AI. Everything is AI enabled, everything is AI driven. Networks of the future are itself AI enabled. This means that we have to rely on some machine to help us to support the actual network operations with stuff like anomaly detection and triage of incidents, right? Classification of incidents, escalation of incidents, and so on and so forth. AI-driven self-healing is a thing that's being developed and baked in the networks of the future. And of course, these networks will be hyper-scalable in the true sense of hyper-scalability, and will offer hyper-integration because they have to integrate with pretty much everything, while being medium agnostic. You could see this network of the future, and again, I could refer here to 6G or 7G or 8G, doesn't matter. It's something that goes through different mediums, right? It goes through the whatever frequency band your radio access capability, the radio access capabilities of your phone is using, and then that other device connects through Wi-Fi, which in turn can connect to satellite, and then end up communicating to some cloud. This medium agnostic, platform agnostic approach is a key point of networks of the future. And all these capabilities will essentially enable current SLAs multiplied by 100. And this 100 figure is not something that is not wishful thinking. There have been some tests run by different vendors and different companies all across the world, in North America, in Europe as well, and we have in-lab testing with mobile communications over radio, over some kind of spectrum, reaching speeds up to hundreds of gigabits per second. And speed, of course, bandwidth is just one such SLA. Anyway, let's go through some of the challenges in what orchestrating security in these networks are going to impose. First of all, they're multi-domain. Multi-domain meaning that your asset, your cell phone, your whatever, your IoT device, your connected car, could roam through multiple operators. They do now. They do it now, but now while referring to roaming, most of us refer to actual international roaming, right? So leaving your home operator and crossing the border to another operating. What multi-domain here means is that one device could roam, for example, through a private network owned by an entity, right? And then from that private network to move to a public one, owned and operated by Orange Romania, for example, and then skip the move from that one to another operator's network. This means that the control planes and data paths are extended way beyond what 5G now is capable of, to the internet, basically, and to the clouds. And this is a challenge when it comes to orchestrating security response. These networks are going to be multi-vendor. Most networks are, as of now, but to some degree there is some collusion and there is some consolidation of the various components of current generation networks through to one or maybe two vendors. But now each provider, such as the telecommunication operators, cloud providers, security providers, various data services, they operate their own stack, right, of technology. So it's not just telcos. It's not just telecommunication operators. You don't have to deal with the likes of Nokia and Ericsson and Samsung, right? You have to deal with providers of other of technologies that are service agnostic, right? They are not solely they are not used exclusively by telcos, but they can be used, for example, by some hosting provider. So you have to have the capability to integrate in your orchestration capacity those technologies as well. Massive IoT. There is a high probability that by 2030 there will be multi-billion connected devices through to the networks that will exist by then. There's a possibility that that these IoT class devices will surpass the traditional user equipment that we all use now in terms of numbers, right? There are maybe 4 billion people connected to the internet, and maybe 4.5 billion people that are using cell phones and smartphones. We could easily multiply that number and still not get the envisioned number of massive IoT devices connected to the network. Orchestrating the security response to such a huge number of assets will require some great scalability. Then you have fragmentation, because the state of the art, what we do now in orchestrations, such as SOAR models and playbooks, are heavily fragmented. There is some common ground as of now in defining some common type of format and scheme that will allow us, for example, to export some playbook defined for some vendor X type of SOAR, and then allow you to integrate it in your vendor Y SOAR, right? But as of now, we don't have a standardized approach, so we have fragmentation. Orchestration in XG networks should keep that into account. And then, of course, you have regulatory and compliance pressure. And this is on the telco world, because one thing that you probably know, but I'm going to say it nevertheless, the telco world is heavily regulated. We have an overhead on compliance. Compliance is very costly, but we strive and we do our best to maintain compliance with what the regulators are asking of us. And that cost usually extends through multiple years. So, integrating new technology is always a bit challenging for service providers that need to maintain a very strict regulatory compliance. So, this is the now we're diving into the technical part of the pitch. What does multi-domain essentially mean? Well, in this representation here, I did my best to draw a data plane, a control plane, and an application plane for, like general usage of some type of network. But in the lower part of the slide, you could see that you have operator A running some services in an edge, right? And you have some type of device connected to that edge. Let's say that that device is actually a series of surveillance cameras from one large city in Romania, and they connect through XG to that edge, and the edge does some processing on the video feeds, like anonymization and scene detection and stuff like that. Then the data path will then move through another operator, through their cloud provider, because the vendor of that application, for example, relies on operator B to store their backends, right? And then that backend will communicate through the internet to some private mobile network in use by a public administration of sorts of that city, where they keep their actual operational capacity. These are 4 separate domains with one data path from one end to the other. And from a security perspective, you need to have the capacity to monitor and orchestrate some type of response to a given threat. And you need to do it through all those domains. This is something that is very, very complicated to achieve in 5G networks as of now, but is something that we are working to develop and to do far better in the networks of the future. And the idea here, the need here, is to have continuous monitoring, detection of incidents, and response actuation, right? You need to be able to, again, circling back to my example with a multitude of video cameras, right? You need to have some sort of control over each video camera, right? If one such video camera is to become compromised by some means, I don't know, maybe a very inventive malicious actor finds some exposed API or interface or whatever and gains control of that camera, you need to have the capability to orchestrate your response and maybe isolate that device from the network or move it to a more secure slice, for example. And you need to do it through the different domains. You need to have detection capability, and that should be baked in each of the domain that your continuum actually crosses, and of course you need to actuate your response irrespective of where the response needs to be actuated. So if you need to configure some firewall in the 5G core of operator B, you need to have the capability. You need to have the drivers in place. You need to have the various translators and policy translators and pushers in place. But if you need to black hole the interface of a camera, you need to do that in the radio access part of operator A. So again, you need to have that capability in place. And I know that the slide is it has all the pretty colors, but it's actually very, very difficult to achieve at an operational level. And this actually leads us to what is the state of the art in 5G security orchestration. So 5G is current 5G, what we're connecting to with our mobile phones, for example. The management and orchestration specifications are defined by 3GPP through those standards. The standard is readily accessible for everyone, and you can find the specifications, plural, because there are many. I believe there are maybe hundreds of such specifications for what management and orchestration should do in a 5G network, right? The standard, of course, does not impose a certain vendor, right? That's regulatories and compliance. But again, the standard is there and we need to follow it. The current the current tools for orchestration are multi-domain aware, but it's mostly policy-based, and the domain types are fairly limited to maybe one operator and then some public cloud type of deployment. Everything is policy-based. So if you are to define a policy that is somehow integrated to some playbooks, you need to have a translation service of sort in order to actually push that policy to the different actuators in your networks. And the orchestration in 5G is heavily vendor specific. There's limited open source support. There's actually, there are some open source projects in management and orchestration in 5G networks, and most of those open source projects are the actual output of research projects financed through the different frameworks of the European Union mostly, and with some, of course, with some research done in North America and in Asia. But in commercial networks, the security orchestration is very vendor specific. So if vendor X, for example, and I'm not going to name vendors, is not that that inclined to open up some API for you or to add some functionality to an existing API because you want that functionality, well, there you go, you are stuck in that precise environment. And of course, on top of everything, there is always the human in the loop. I do not believe that there are any network operators, telco operators, at least none that I know of, that rely on automation for pretty much everything network operations related. There's always a human in the loop. And the human in the loop is the actual decision maker. But this, in the state of the art in current 5G networks, this limits the intent awareness of the orchestration tool. The orchestration is based on policy, so it cannot actually have some sort of predictive capability in order to see that action X leads to result A, and then that leads to action Y, which leads to result B. So there's always have to be someone in the loop to click on things. But we are moving past the state of the art with a body of research that's now concentrated, at least in the European Union, in a framework on Horizon Europe, a framework that's called SNS. And this framework allows companies such as Orange Romania to address some of the challenges that we've discussed in my previous slides. Rigorous is one such project, and we are part of the consortium that researches and tests and validates the outcomes of this project. It stands for Secure Design and Deployment of Trustworthy Continuum Computing 6G Services. That's a mouthful, I know. Usually acronyms are. But what the project aspires to do is to identify and address some trust and privacy issues threatening the various networks and devices in networks of the future. So the key objectives here is to develop, test and validate this framework that will secure the continuum that I was describing earlier, while maintaining a DevSecOps human-centric approach to actual operations. Everything should be based on AI models. And there is a need to demonstrate this framework in a set of industry-relevant use cases and in operational environments. And we, Orange Romania, are one of the use case owners, and we have our specific use case for orchestrating networks of the future using the framework developed in Rigorous. The overall architecture of the framework consists of, well, it's essentially two parts, the design part and the operation part. The design part deals with defining the policies, defining the models that are going to be in use to orchestrate the security in next-gen networks, while the operation is the actual integration layer. This stands between the design and the operation part, the design part and the actual networks, the actual infrastructure. One of the things that Rigorous is pushing to achieve is intent-based security management. This basically requires of an operator to have a rich enough output coming from all the tools that are used to actually run the network, so in the run phase of the network, in order for the framework to have the capacity to go past policy-based network management and to actually predict the intent of both operators and malicious actors. And intent prediction is a very high reward type of activity in AI land, and this is why most of the partners in this project that I'm addressing are various universities and research entities across Europe that mostly deal with AI. And what we're trying to have here is various levels of assessment, definition, and management for the policies that we use to operate our networks in order to feed forward this tool that's developed in Rigorous, which in turn will provide our operators with some form of relevant intent margin. in our use case, and I'm going to go to the use cases immediately, that means reinforcing the decision-making part of the human operator in the loop. So what's the end-to-end workflow here for these tools? We have a user interface where it's a modeling tool, essentially, where in a friendly manner and using some high-level language, the operator will define their network policies, right? This UI then communicates via some API, some REST API, to the actual intent-based security management component. This is a module that will input the human-centric representation coming from representations coming from the SMUI from this modeling tool, and then output it to the various drivers and actuators in the orchestrator, and that's the third part right there. And of course, the orchestrator will essentially use the drivers and the integrations to actuate response on the infrastructure. This is a workflow that's typical for a SOAR of sorts. The main difference here is that this modeling tool will act as a translator for intent-based policies, and will add the AI magic, whatever, to the actual orchestration of events. The AI-driven part of this platform, well, they use different models that are trained on data sets coming from the use case owners and the industry partners that are part of the project. We are providing this project with data sets that are related to our telco business. And they use that model to train specific response for specific actions, right? Again, nothing new here. There's a federated learning approach for the decision-making part of the orchestrator, and because it is topical, so it is industry-specific, the orchestrator will, of course, consider some some elements and some metrics that are telecommunication specific, right? Such as the various QoS SLAs that we use for our commercial services. The human-in-the-loop approach here will essentially mean that the operator will pass on the responsibilities of actual incident detection and classification to this tool, to the framework, and then will reinforce the output of the framework, will reinforce the decision, and will, in a given time frame, we'll have to actually validate the decision. Once we go, because it's reinforced learning, right? And once we go through a number of cycles for each reinforced decision, then the credibility of that decision will increase. So the orchestrator will learn from the intentions of the operators and will gain automated capabilities to run the same decision in a similar loop, right? And the orchestrator will then be able to change configurations, settings, to deploy things, to collect artifacts on all the domain-specific components of XG networks, right? The end-user equipment, the radio part, the edge part, the transport, the core, and everything that's inter-domain, right? Private clouds and such. The policies here, because the orchestrator is supposed to be intent-based, so the policies are merely a primitive for actually deriving the actuation from the decision-making algorithms. But the policies are designed in this project to be part of a common repository. So there is just a single point of ingestion for everything that's playbooks, I don't know, sticks 2.1 type of artifacts and schemes. Everything is plugin based, so third party can write their own plugins if type of equipment or some technology is not supported out of the box, then we can provide the SDKs and the API specifications so that plugins can be very easily deployed, written and deployed. The policies are proactive and reactive. So this is these are the two types of policies that we're considering for this project. And we heavily rely on drivers reutilization because we need to demonstrate this orchestrator in an industrial relevant environment, and we are going to use our own testbed for the industry relevant environment, and we already have the drivers for the various components in that testbed. We do not want to reinvent the wheel and actually redesign and develop drivers that are already there. And of course, everything needs to be end-to-end. What are the use cases? It's just one use case, but with two different scenarios. The first one is that we will try to orchestrate a response to a cybersecurity event targeting unauthorized access to a XG infrastructure through privilege abuse. So this is an insider threat. The kill chain here should start with some oral employee, disgruntled employee that has access to the administrative, to the control plane of our facility. They log in from an unsanctioned terminal, and they, of course, perform some changes on a VNF. And this, the changes they perform should disrupt some service availability and integrity, and that service is actually a B2B service of one of our customers. Of course, everything that happens in this scenario is simulated in a test bed, so we will not touch any service of a real B2B customer of ours. Then the malicious actor, the employee here, well, they move laterally through the 5G facility, they gain access to the virtualization control plane, and what they do is that they migrate some containers from a production environment to a UAT environment, which in turn leads to service disruption. This is the one of the scenarios. The second scenario is more close to home. Essentially is a DDoS attack on an edge service of Orange Romania. The service is a web portal, some front end of a B2B customer of ours, and that portal is actually deployed in an edge. And you have this large swarm of IoT-based botnets targeting that edge in order to disrupt functionality. We are right now we are at month 18 of a 36 months project, so we are almost at the half of the running of the project, and we are now focusing on this scenario for the demonstration that we will have in that project sometimes in the next 12 months. The use case and the scenario will be demonstrated in Orange 5G Lab. Orange 5G Lab is, well, it's an development, prototyping, and testing environment that has been developed with partner universities. We now run 2 instances of this testbed, one in Bucharest, in the campus center, in the Polytechnica University of Bucharest, and the other one, the Gheorghe Asaki Technical University in Iași. These testing environments are designed to replicate production XG networks at scale, of course. But this is the main goal of such an environment. And they are fully integrated DevSecOps environments in the sense that they can communicate with our network operations, our security operations. We have the tools, we have the CI/CDs and whatnot in order to actually automate through the DevSec lifecycle. They are fully compliant with 3GPP release 16, and we are upgrading them to release 17 as soon as release 17 will be out of beta. And they are heavily collaborative. These environments are meant for us, Orange Romania, to extend our capabilities, our testing capabilities, our facility capabilities to academic partners, to researchers, to entrepreneurs. Maybe it is the case for some of you. So if you want to test some 5G, 6G, 8G, whatever G application, this is the environment that you can do it to. because it's a very close replica of a production environment. The Orange 5G Lab is multi-domain capable. Because what we can do is we can actually replicate 2 different operators using the 2 different 5G labs, the one in Iași and the one in Bucharest. And even we can go even further, and we can actually just split the resources in multiple federated segments and replicate a large number of domains, actually. From a performance standpoint, I believe we're up to 3,000 plus CPU cores, some terabytes, 20 plus terabytes of RAM, and up to 200 gigabits per second network connectivity between some of the components. So this is the kitchen in which we are trying to cook the rigorous recipe. The use case piloting, well, it's the DDoS use case, and this is a representation of what we're trying to achieve. We are going to simulate 2 domains. One of the domains is going to be simulated in the Orange 5G Lab facility in Bucharest. The other one is going to be simulated in a partner university, a partner of the project, the University of West Scotland. They have a smaller scaled lab. And what we're trying to achieve here is to have a swarm, a botnet, deploy an attack, a DDoS of sorts, to a victim machine that is going to be in a 3rd domain. That's a private cloud, right? Private cloud, but of course with some front end of the machine exposed to the internet. And the orchestrator, the actual orchestrator is going to be deployed in the 1st domain, in our 5G lab, but the detection of the events and then the actual response planning is going to take place in the 2nd domain, in the University of West Scotland land, right? The orchestrator will receive data from some of the components that are deployed in this 2nd domain, and based on the data it receives and based on the intent that it perceives from the policies and the operator in the loop, the human in the loop in ORO's Security Operations Center, will then decide on an action, a mitigation action. That mitigation action is going to be actuated through the usage of some drivers. Most of the drivers are open source, some of are specific to the technology that we use in our testbed, for example. The response we want to validate is first an actuation to migrate this victim machine to a secondary healthy cluster, because the first cluster in that private domain is going to be affected, at least some of the interfaces are going to be affected by that DDoS. So we have a second healthy cluster. That cluster could be anywhere on Earth, so in a 4th domain, maybe a 5th domain here. As long as we have access to that cloud controllers, we can actuate the mitigation action and move that victim machine, or at least spawn a replica of that machine to a healthy cluster and do all the necessary network configs in that cluster in order to push legitimate traffic to that machine, that new machine. This is the first response. The second response is to take all this bad traffic, the DDoS traffic, and not scrub it. We don't want to scrub it. We don't want to sinkhole it, but we want to isolate it. We want to isolate it specifically for research purposes, because it's a fun thing to do. And we are going to use network slicing, is one of the concepts and one of the technologies that's baked in 5G as of now, and I've discussed it in some of my first slides. We are going to create a slice, so imagine this as a large pool, an empty pool, and fill that pool with the DDoS traffic. Essentially route all the traffic, because we have the routing capacity, and route all the traffic to that pool. And once that pool gets filled to the brim, we can then evacuate some bad traffic out of it and send it to the internet, but only with a profile of 10 kilobits per second. This is basically a very, very smart way of mitigating DDoS attacks without having to deal with the DDoS mitigation cost of doing business. And the scenario here is, what we're trying to validate is that the rigorous platform, the one that is being developed in this project, will act precisely as as I've described here. Because this is intent-based and this is heavily automated. We are trying to make sure that the machines will drive the correct decisions and end up pushing these specific policies and not other policies. We are going to give the machines the choice of different set of policies with different configurations, but by validating this use case, we are trying to achieve this specific matching between the use case description and what the machines actually do. As key takeaways, and thank you for your patience, we are now 2 minutes into lunch. 5G and future networks are heavily complex. The networks of the future are going to add to that complexity and bring this to a whole other level. So we need to have visibility. We need to have tools that enable us to automate various responses to threats. And this complexity usually means a larger attack surface, because we add devices, we add assets, we add user equipment, we add vendors, we open up new supply chains. So everything is up for grabs for malicious actors. The devices, IoT security is pretty much broken. We are at a security conference, so I'm fairly confident in saying this. We could maybe try bootstrapping some code into some specific type of IoT controller platform. People have tried to do different things with IoT security for some 2 decades now, but we are up to the point that most security actually happens not on the device, not on the run part, not even on the transport part, but if it happens somewhere deep in the network, way too close to very, very important stuff in the network. So we need to take that into account. We need to address this security closer to the device, not closer to the network. And 5G and beyond 5G actually enables us to move security at the edge. The edge meaning, in this context, the edge is the least unstable part of the network that can actually alleviate some of the malicious things coming from the devices, right? It's not close to the core, it's more close to the billion of devices that are going to connect to the different networks. Threats. There are new threats coming, coming. We all have access to CTI feeds. I'm not sure that I need to reinforce this point here. But the 5G security and beyond 5G security means that we need to comb through the threats. We need to do a good job of actual threat management and actual vulnerability management. This means that we'll probably have to rely on AI, some AI of sorts, because as opposed to, I don't know, some third party, some service provider of sorts, we as telcos, we have to deal with multi-million devices connecting to our networks, some of them at the same time, so we don't have the luxury to pinpoint and evaluate closely each of the various assets, or at least to classify each asset as it connects to the network. So orchestration is essential. We cannot have reliable and safe XG networks without orchestration. Some of you are probably pretty bored by now, but thank you for pulling through. I hope that it was at least informative in the sense that it gave you maybe a bit of a touch of what 5G and 6G, 7G is actually about from a security standpoint. And I don't think I want to take up your time with Q&A right now. Maybe we should go to lunch, and if you want to discuss something, I'll be in the lobby until probably 6 o'clock. Right? Thanks.